Hi guys, can you hear me? You can answer in the chat box if you can hear me. Yes. Okay, good. I hope you guys are having a good holiday. Uh, no video. Okay, I'm about to get that. Okay, can you see my screen now? Yes. Okay, good. Move that over here so you guys can answer the questions over here. Okay. So today we're going to be talking about perimeter and area. So first off, some abbreviations. Uh, Basically, P, perimeter, A, area. Or you can set S as area too, it doesn't matter. L, length, W, width, H, height, C, circumference, R, radius. Hopefully you guys are all know what these terms mean, like circumference, it's just like the outside of a circle, radius of a circle. Okay, onwards. So here's some basic formulas for a triangle. So first off, the perimeter of a triangle, it just basically equals the three sides added together. So like triangle, it's your triangle, A, B, C, side A, side B, side C. The perimeter is equal to A plus B plus C, really simple. The area of a triangle is equal to 1/2 base times height. So what this means, like if our triangle right here, the area would be, so this would be the height. The height is basically a line 90 degrees down to your base. And in this case, our base is C. So the area of the triangle is 1/2 base times height. So it'd be 1/2 this times this. So that's the area of any triangle 1/2 base times height. For an equilateral triangle, since all sides are equal, like let's say this is my equilateral triangle, all sides A, the formula for the area, you don't have to do 1/2 base times height. Since it's an equilateral triangle, you can just basically, all equilateral triangles, the formula is going to be A squared square root of 3 over 4. No matter what the length is, it's always going to be, this is going to be the area. Okay. So remember, try to write this down and memorize it. This is a really important formula. It speeds it up really quickly. A squared square root of 3 over 4. Okay, onwards. So there's just some charts. As you can see, all triangles have a base and a height, and you find the area by 1/2 base times height. For a right triangle specifically, their height turns out to be one of the lengths, one of the side lengths, so you can just one length times another length divided by 2. Okay, so try this example just to get us going. What is the area of a triangle whose base measures 12 centimeters and whose height is 10 centimeters? Right, so this one should be pretty easy. Nice job to the guys who got it down here. It's just base, which is 12, multiplied by height, which is 10, divided by 2. So it's 120 divided by 2, which is 60. So 60 right here. So let's try example number 2. This one's really similar, so just see if you can solve it real quick. All right, nice job to the guys who got it down here. Correct answer is 90. So this one's just like the same thing. Since it's a right triangle, one of the legs will be the base and the other is going to be the height. So it's just 1/2 base times height, 1/2 10 times 18. So this equals 90. Okay. Okay, so try example number 3. This one, if you think about it, it's basically like a little bit of a proof of how to why the formula for a triangle area is what it is. Right, answer is 12. Should be really easy since it basically it's just like half of 24, which is 12. So if you think of it, the area of the triangle is going to be base. So it's just like the area of a rectangle divided by 2. So it's like base times height divided by 2. That's another way to think of it. Okay, so let's try a Math Counts Handbook problem. The area of a triangle is 12 square units and its height is 6. How many units are in the length of its base? All right, nice job to the people who got it down here. The correct answer is 8. Um, so this one's pretty easy as well. It just says area is 24 and it's a triangle, so 24 equals 1/2 base, which we don't know, so I'll call B, times height, which is 6, and solve for B, which turns out to be 8. Okay, onwards. Okay, so we just covered triangles really briefly, so now it's on to rectangles. Rectangles, you guys should already know that the perimeter is just all the sides summed up, 2 lengths added to 2 widths, and the area is just length times width. It can be thought of as 2 triangles, so it can be thought 2 triangles or like it is 2 triangles. Same thing for parallelograms. Okay, nice and easy. Let's try this example. What is the perimeter of a square whose edge measures 12 centimeters? Right, so this one is pretty thoughtless. Nice job, guys, who got it down here. It's just 4 times the sides. So 4 times 12, 48. Math Counts Handbooks. Okay. Example number 2. The area of a rectangle. What is the area of a rectangle whose length is 9 and width is 8? Whose length is 9 and width is 8? Right, nice job. I think everybody got it in the end. The answer is 72. Rectangle's area is just length times width. 9 times 8 equals 72. Okay, let's try this example. What is the perimeter of a rectangle whose length is 13 and width 8? Right, nice job, everybody. The answer is 42. Uh, Again, it's just, oh, that's a really large number. Okay. It's just 13 plus 8 times 2, which is 21 times 2, which equals 42 in the end. Okay, so parallelograms are just like rectangles. So let's try this problem. What is the area of a parallelogram whose base measures 14 centimeters and height 9 centimeters? Right, nice job, everybody down here. It's just base times height, 14 times 9, which is 126. Okay, so onto a slightly harder one. A rectangle is cut from the corner of a larger rectangle as shown. How many feet are in the perimeter of this shape? So what is the perimeter of this shape? I'll do my best to draw it over here real quick. Right, nice job, guys. The answer is 22. You guys, the easy way to think of it is basically to just pull this length right here down, and then pull this length over here to the left. So basically this right here becomes this, and this right here just becomes this. So it's just basically a rectangle and asks for the perimeter of a rectangle. So that's a quick and easy way to think about it. So like as shown in the picture here, pull down, right, and it's just perimeter of the whole rectangle. So let's try this one. How many square feet are there in the house with dimensions shown in the figure? This is from Math Counts. Right, I'm still waiting to see if anybody can figure out this problem. Nobody's gotten it right, by the way. I'll give you guys like a few more seconds. I'm just drawing it out right now. Oh, what is that sound? Right, nice job, Robert. You're the only one who's gotten it so far. But it's okay, I'll explain it real quick. So if you read, right, you have the right idea, but I don't think you calculated it right. Yeah. So just be careful in calculations. So first off, this is, if you look at it and you pull these out to the side, you figure out that this is a square, and it's actually a 40 by 40 square. So you just write that, 40 by 40, which equals 1,600. Oops. It's a little hard to write with this. Okay, but that's not what the question asks for. The question says how many square feet are in the house with the dimensions shown. What we have found is this square's area. So we have to take the area of the square and then subtract the area of what we like filled in here. So it's 1,600 minus this little square here, which is 11 times 12. And if you do your calculations correct, you should get 1468. Right. So just remember to read carefully, and yeah. Okay. Let's continue. Okay. Let's try this problem. ABCD is a 4 by 6 rectangle formed by three 4 by 2 small rectangles. And B and E are the centers of arc AG and FC. Find the shaded area. Right, so since this one isn't really a calculation, I'll just tell you guys. Nice job to the people who got it down here. The answer is 8. I don't know if you've seen it before, but this is really easy if you've seen it before, or if you just like figure it out. Um, if you look closely, you see that NGC, this little shaded portion, fits perfectly in with MEG. So basically, you push this here, and then AMF fits perfectly with FH in. So you push this portion over here. So it just basically turns out to be the area of just one rectangle, which is 4 by 8, which is 8. So that's just a quick, either you know it or you don't know it. So good to know. As you can see, this graph kind of helps you visualize it a little better. Okay, so we've talked about triangles and rectangles, so on to the third figure, which is trapezoids. Trapezoids are basically rectangles, except for they have different bases. So still quadrilaterals. Okay, perimeter of a trapezoid, really simple, just add all the sides together and you're good. Area of a trapezoid is base 1 plus base 2 times height divided by 2. So it's good to memorize this if you haven't already. So it can also be thought as two triangles added together. So it's like this triangle, area of this triangle's base times height divided by 2, and this triangle base times height divided by 2. And then that's where you get this formula from. But it's good to memorize it. So it's just base 1. So the bases are the two lengths that are parallel to each other. So base 1 plus base 2 times the height divided by 2. So just good to memorize that. Okay, so let's apply that to this example. What is the number of square centimeters in the area of the trapezoid shown below? Right, nice job, everybody. The answer is 36. So it's just base 1, which is 6, plus base 2, which is 12, times height, which is 4 divided by 2, 18 multiplied by 2, answer is 36. Okay, so let's try this one. This one requires a little bit more thinking. If the perimeter of the trapezoid is 42, what is the number of square centimeters in its area? Good job to everybody who got 100. That's the correct answer. So this one is kind of like a two-step. First off, you know the perimeter is 42. And you know that the area of a trapezoid is base 1 times plus base 2 times height divided by 2. But you don't have base 1, and you also don't have base 2. But what it does give you is base 1 plus base 2. So if the whole thing is equal to 42, the two sides that you don't have added together is going to equal 42 minus 12 minus 10. So base 1 times base 2 is going to equal 20. Base 1 plus base 2 is going to equal 20. So the area is just going to be 20 multiplied by 10 divided by 2, which is equal to 100. Okay. So here's kind of a figure that it's not really talked about much, but it's still used. It's called a rhombus. So it's basically a square, except for the sides aren't at 90-degree angles to each other. So perimeter is going to be, since it's like a square, all the sides are going to be the same. So perimeter is 4a, and a being one of the sides. And the area is basically the two little crosses, or the diagonals, multiplied together divided by 2. That's easy to memorize. Doesn't hurt to know that. So it's just diagonals multiplied divided by 2, and the area the perimeter is given. Okay. So let's try this one. Find the area of a rhombus whose diagonals have lengths 4 and 9. Right. Nice job, everybody. Answer is 18. Kind of self-explanatory. Just multiply the diagonals and divide by 2. So like, if you knew this formula, you get this problem right. If you don't know the formula, you have a chance, but you probably won't get this problem right. So it's just good to know. Diagonals multiplied together divide by 2. Really quick and easy to memorize. Okay, on to circles. So here's a circle over here, and the length from the center to the outside of a circle is its radius. The circumference or perimeter of a circle is equal to 2 pi r. Pi is just 3.1415. It continues onward. Some people like to memorize pi to a really long length. But basically all you have to know is 3.14, and onwards from that is kind of irrelevant. So the circumference is just the perimeter, 2 pi r, 2 times pi times the radius. The area is pi r squared. So just pi multiplied by r squared. You can also replace r with d, because d over 2 equals r to get that formula. That works too. D is diameter. Okay, so you guys should already know this. If you don't, you have to memorize it. Okay, sectors. Sectors are a little bit harder to grasp, so I'm just going to briefly mention sectors. So sectors are just like portions of the circle. They're like kind of pizza slices. So the length of this is basically 2 pi r, so the total circumference multiplied by the proportion of this angle to the whole angle, which is 360. Area is the same thing. It's the whole area multiplied the proportion of this angle to the whole angle, which is 360. That's just good to know really quickly. Okay, so let's try this example. What is the area of a circle whose radius measures 4 centimeters?
Radius. What?
Right. 4 times 2.
Yep. Area is 4 squared.
Right, the answer is 16 pi. Nice job, guys. Make sure it's still on. Okay. The answer is 16 pi. So it's just per the formula pi r squared. So it's you can't forget the pi. So it's always there's pi. So you just write pi, and then r squared, which is 4 squared, which is 16. So 16 pi. And this is basically always the form that you can leave it in. You can also do it to a decimal, and then you'd have to round it. So it's not as precise. So this is correct format. Okay. So what is the radius of a circle whose perimeter is 64 pi? Oh, a lot of conflicting answers. I did say perimeter, right? So if you read carefully, it says radius of a circle whose perimeter. I might have said area. I don't know. A lot of conflicting answers makes me think that I said area. But it's actually what is the radius of a circle whose perimeter is 64 pi? Right. So if it said area, you guys would be correct up here. It'd be 8. But it's perimeter, and we know that perimeter is 2 pi r. So that equals 64 pi. Right. So nice job to everybody who got 32 in the end. I think everybody got 32 in the end. So it's just, you have to read carefully. Sometimes math counts like throws this stuff at you. So read carefully. 2 pi r equals 32, solving. Okay, so let's try this one. What is the radius of a circle whose area is 64 pi centimeters squared? Right now it's 8, so you guys are just answering for this question, right? You knew what I was going to ask later. So it's just, we know that area for radius is, for the area for a circle is pi r squared. And then that equals, it tells you it equals 64 pi. So if you solve that, basically you find that r equals 8. Okay. So let's try example number 4. If the circumference of a circle is 8 pi, what is its area? This one's kind of a two-step problem. Right, nice job, everybody. The answer is 16 pi. So like when I said two-step, basically you have to find the radius first. So if it's 8 pi equals 2 pi r equals 4. And then after you have the radius, you can find the area pi r squared, pi 4 squared, which is 16 pi. I'm gonna skip this one. Okay. So ellipse is kind of like rhombus. It's a shape that is sometimes used, but it's not used quite frequently. So ellipses are basically just ovals. So they're like flattened circles. So normally if this was a circle, then A would equal B, and that would make it a circle. But in this case, it's an ellipse. So the area is equal to pi times A times B, so pi AB. So pretty easy to memorize, just pi AB. So like, for example, if A were to equal B, it would just be pi A squared, which is the same thing as a circle, pi R squared, area of a circle. So that might help you think of it. Perimeter is 2 pi A squared plus B squared over 2 square root. That's a little harder. I don't know if that will be very useful. I know this will probably be useful, but I'm not sure about this. It wouldn't hurt to memorize this though, so probably should write it down and memorize it. 2 pi square root of A squared plus B squared over 2. So it wouldn't hurt to memorize it, but might not be used. Okay, so let's try this problem. A tennis racket is elliptical in shape, so this is elliptical. The formula for the area of an ellipse is A equals AB pi. So this one actually gives you the formula, where A is half the width and B is half the length. If the racket shown has a hitting surface of 35 pi, find the number of inches in the width of the hitting surface. So it gives you the area this time, it gives you one of the lengths, and it asks you to find the other one. Oh darn, everybody is saying 5. Huh. Let's read the problem one more time and then let's see if the answer's still 5. It says A is half the width and B is half the length. And the question is how many inches in the width of the hitting surface? Okay, I'll explain this problem real quick, but nice job, whoever got 10. The correct answer is 10, actually. I'll explain it. So it has the area equals AB pi, and it gives you the area of 35 pi equals, and it says A is half the width and B is half the length, and it gives you the length. So half the length is 7, multiplied by half the width, which we don't know, so we'll call it B, multiplied by pi, right? So through this, we solve B equals 5. Oh, that's a weird B. Okay. B equals 5 quite easily, right? Most everybody got here. But we forgot that B is equal to only half the length. Or half the width, doesn't matter. Okay. It's only half of what we want. So what we want is actually double this. So yeah, 10. This would probably be A. This would probably be A. And it says A is half the width, and it says how many inches in the width. So just double whatever you had before, yeah. So the answer is 10. So again, to reiterate, you got to read carefully. You see that A is only half the width, and it asks for the whole width, so you double it. So read carefully. Okay. So on to the next theorem or kind of formula. This one's really important, so you should all try to memorize this one. It's called Heron's formula. I think that's how you say it, Heron's formula, and it's just this formula here. It looks really simple, well, kind of simple, but it's also really easy to memorize, and it's really helpful. So this lets you find the area of a triangle that you have the sides of, but you don't have any of the heights. So we know that an area of a triangle is base times height, but it divided by 2. But if you don't have height, you won't be able to find it unless you have all 3 sides, and then you can apply what is called Heron's formula. So Heron's formula just basically says that area is equal to the square root of S multiplied, S is semi-perimeter, I'll explain that later. S semi-perimeter, so just first off it's the square root, and then first semi-perimeter, and then semi-perimeter minus one side, multiplied by semi-perimeter minus the other side, multiplied by semi-perimeter minus the third side. So that's Heron's formula. So what is semi-perimeter? So since you have all three sides and you're trying to find the area, the semi-perimeter is basically the perimeter divided by 2. So all sides added together divided by 2. So again, would be great if you memorize this formula. Area equals square root semi-perimeter multiplied by semi-perimeter minus one side, semi-perimeter minus second, semi-perimeter minus third, all under the square root. Semi-perimeter is just half the perimeter. So let's try, so real quick, do this one right here. Find the perimeter and the area of a triangle with side lengths 21, 28, and 35. And normally when you use Heron's formula, the numbers under the square roots usually come out to really nice numbers, but sometimes they don't. So this one might take a little bit, so I'll kind of start it over here while you guys work on it. Yeah, sure. I will be after class. That'd be good. I will be there. Right. Like you said, it is just inputting the numbers into the formula, but also helps you memorize the formula, which would be best because this is a really widely used formula. So after you have this, nice job everybody who got here. Answer is 294. After you have this, the numbers turn out to be really nice actually, because what's this? It turns out to be 21. This turns out to be 14. And this turns out to be 7. And then they're all under square root. So since this is 21, 42 equals what? 21 times 2. So basically you have a 21 here and a 21 here, so you can take out a 21. This one is 2 times 7. You have a 7 here and a 7 here, so you can take that out. And then you have a 2 here, and then you have a 2 here, so you can take that out. And then multiply these three together, and you get your answer 294. So that's how you do it without a calculator. So since it's under square root, you search for the ones that are the same multiplied together, and you take them out, and it becomes a lot simpler. So usually if a problem requires you to do Heron's formula, then the things under the square root come out really nicely. Okay. Okay, this is also a really helpful theorem. Math Counts AMC likes to use it a lot. So I remember one year they just had this square and it gave you three of them and asked you to find the fourth one. And you could do it instantly if you knew how to do it. So it's just basically if the rectangle is divided into four smaller rectangles, the following relationship is true. The crosses multiplied, so x and v, is equal to the other crosses multiplied. So x times v equals u times y. So it's nice and easy to memorize, so you should memorize it. Just x times v crosswise is equal to the other cross y times u. So this times this is equal to this times this. Nice and easy. Okay, so for example, AMC used this 1994. A large rectangle is partitioned into four rectangles by two segments parallel sides. So it gives you three and it asks you what is x. So how about you guys try and solve for x? You can leave it in a fraction if you want. Right, nice job everybody. The answer is 84 divided by 35. So it's just cross multiplied divided by the one on the bottom. So this one's wrong, this solution. So if you're going back and checking the notes, which will be posted, this is actually wrong. So it's just cross divided by cross multiply is equal to each other. Okay. We'll talk about Pick's law real quick. Okay. So Pick's law is if you have sometimes math counts likes to use this. It's basically the area of a figure that's bounded by grids. So so basically normally all Pick's laws and math counts are going to be, or AMC are going to be using a rectangular grid, but it doesn't hurt to also know a triangular grid. So rectangular grids are really simple. It's just 1, 2, 3, 4. Just like a regular normal grid, you know. That's not really a good representation, but it's just normal grid. So like right here, this would be a grid. Okay, the area is equal to b over 2 plus I minus 1. So what b stands for is the number of points on the boundary of whatever figure you want divided by 2 plus I, which is the number of points inside your figure minus 1. So keeping that in mind, see, I don't know if you can see this really well, so I'll zoom in a little bit. Okay, see if you can find the area of this figure right here. So remember that the formula is b over 2 plus I minus 1. Boundary over 2 plus I minus 1. Right, nice job to everybody who got it down here. The answer is 6. You add up the number of points on the boundary. So 1, 2, 3, 4, 5, 6, 7, 8. You count 8. That's 8 divided by 2 plus the number of points on the inside. 1, 2, 3. 8 plus 3 minus 1 gives us Oh wait. Oh, sorry. 8 divided by 2. So 4 plus 3 minus 1 gives us 6. You have to be like, what? Okay. So let's try this figure. A little more wacky. See if you can get the area for this figure. Okay, let's not mute me. Thanks. Okay. Nice job to everybody who got 14. That's the correct answer. So again, we just apply Pick's law. Add up the number of points in the boundary. 1, 2, 3, 4. If we count them all up, and if you count them right, it should come up to be 16. And then plus number of points on the inside, if you count them up, should be 7. And then minus 1 gives us your answer of 14. Let's zoom out. That's good. Okay. I just want to go back and mention real quick. This formula, I skipped over it because I didn't think we would have enough time, but seems like we have more than enough time. So looking back over at this formula, if you read point number 6, this is, you won't see it a lot, but it's still, you'll see it sometimes. It's for if you pick any point T on the inside of this rectangle, you have the formula, if you connect the corner to T, that squared plus, if you connect it to the opposite corner squared, is equal to, if you connect it to this squared, opposite corner squared. So it's just AT squared plus TC squared is equal to BT squared plus TD squared. So anyway, thanks for being here today. I think we're going to end class a little bit early since we got through all I wanted to get through this week. So thanks for being here. I don't think we'll be having class next week because it's the holidays. So have a good holiday, everybody. Thanks for being here. Class next week. I will email you guys about it. No class next week.